So now let's go to the other side of the periodic table and look at the metals. In the previous video, we were working on all the nonmetals, and I showed you how they all gain electrons to become negatively charged anions. Now, going over to the other side of the periodic table with the metals, we're going to talk about how they lose electrons to become positively charged cations. Okay, let's start off with sodium. Sodium has how many valence electrons? If you look at the periodic table, sodium is in group 1A. It has one valence electron. Okay, so technically speaking, sodium has two choices. It could either gain a whole bunch of electrons, which is crazy, to make it look like argon, or think about this, it could just lose one electron and it'll go back and it'll look like neon in the period before. It's so much easier to lose one electron than to gain 7 electrons. Plus, just remember this, metals never gain electrons. Metals lose electrons. So put in your notes, metals lose electrons, non-metals gain electrons. When metals lose electrons, what happens to them? They become positively charged. So when you look at the electron configuration of sodium, it's 1s2, 2s2, 2p6, 3s1. So what's going to happen is that it's going to lose this one valence electron in the outermost shell. And now it goes down to this, and look, it's got the 8 electrons now in the outermost shell. It's now got the same electron configuration as neon. All right, how do we show this? We say sodium loses one electron, and it becomes a sodium +1 ion. Okay, why is it +1? Here's the deal. If you look at sodium, sodium has how many protons? It has 11 protons. So it has 11 protons, and it used to have 11 electrons. Okay, 11 protons, 11 electrons. But now that it lost an electron, it has only 10 electrons. So it has 11 pluses and 10 minuses. You can immediately see that the pluses now outweigh the minuses. We have one extra plus, so that's why we have a +1. You're not gaining or losing protons, guys. Remember, the protons will tell you what the element is, so you don't ever touch the protons. What you're doing is gaining or losing electrons. With metals, they always lose electrons. With nonmetals, they always gain electrons. All right, let's do another metal. Let's say I've got aluminum. Aluminum's got 3 valence electrons. Or let's say I've got calcium, 2 valence electrons. So if you look at the periodic table, aluminum could either gain a whole bunch of electrons and look like argon, but we already said that metals don't gain electrons, so they have to lose. So aluminum wants to lose these 3 electrons so it can look like neon. Calcium wants to lose 2 electrons so it could look like argon. So aluminum loses 3 electrons, and if it loses 3 minuses, that means it has 3 extra pluses, so it becomes an aluminum 3+ ion. Calcium is going to lose 2 electrons, and why is it that it's losing 2? Because it has 2 valence electrons. Why is this losing 3? Because it has 3 valence electrons. Remember, sodium loses 1 because it has 1 valence electron. And then it becomes calcium 2+. The cations, these guys are called cations. are positively charged ions. The cations don't change the name. You just put in the word ion at the end. So it's not like with the anions where you change the name and it ended with an IDE. These guys stay with the same name. So Na plus is just a sodium ion. Al3 plus is just an aluminum ion. Ca2 plus is just a calcium ion. Okay? Now, metals are a little trickier than nonmetals. Nonmetals, they always gain electrons, and that's the charge they always will be. There are some metals that can lose different numbers of electrons. Those are called the variable charge metals. Let's first learn the fixed charge metals, meaning that these metals are never going to change their charges. They will always be this. All the group 1A metals are always going to be +1, always. So lithium will be +1, sodium will be +1, potassium will be +1. What's after potassium? Rubidium will be +1. Cesium will be +1. So all group 1A will all of them lose 1 electron to be +1 cations. Group 2A metals always lose 2 electrons to be +2. So basically beryllium 2+, calcium 2+. What's after calcium? Oops, sorry, magnesium. Let's put magnesium first. It doesn't really matter. Magnesium will be 2+, calcium will be 2+, and then strontium, is that strontium? Yep, strontium, barium. Strontium will be 2+, barium will be 2+. Okay, so they will all lose 2 electrons and become cations that are a +2 charge. Remember, the conventional wisdom is to not put any numbers with the +1 and to put the number before the plus for the +2. Other fixed charge metals are aluminum, gallium. Aluminum and gallium are 3+, okay? And then other fixed charge metals are zinc. It's a transition metal, it's +2. Silver and cadmium. Cadmium, 2+, silver, +1. I think that is it. Those are the ones you need to know. So this is zinc. So fixed charge metals, the ones that will never change their charge, they will always be this. Group 1A will always be +1. Group 2A will always be +2. Group 3A, aluminum, gallium +3, zinc, cadmium, and silver. Okay? Those ones won't change. The ones that will change are a whole bunch of ones in the transition and heavy metals. So the ones that I'll give you some examples for. Iron could either be +2 or +3. Okay? Copper could either be +1 or +2. So just have these in your notes so that when we start creating ionic compounds, you'll know this stuff already. What else? Oh, tin could either be +2 or +4. Lead could either be +2 or +4. I think those are good for now. There are others, lots and lots and lots of others, but these are the ones that we use a lot. So you should know these are called variable charge metals. Now, if it wasn't listed in the fixed charge metal category, then you automatically assume it's variable charge, okay? So that's what I need you guys to do. Which ones are the fixed charge? Group 1A, Group 2A, aluminum, gallium, zinc, cadmium, and silver. Okay? Those are your fixed charge. Everything else, all other metals, let's just consider them variable charge. Okay, so the next video, we will begin to put ions together, cations and anions, to create ionic compounds, and we'll learn how to name them. Okay.